Hi all, today I would like to discuss my views on the topic polygon filling. Let us begin. Polygon filling is a fundamental operation in computer graphics that involves filling a polygon with a color or pattern. So, polygon is an ordered list of vertices. So, in order to fill that with particular colors, we need to determine the pixels falling on the border of the polygon and those which fall inside the polygon. So in this part we will see how we can fill polygon using different techniques. Types of polygon filling. The first type is flat shading. This technique fills the entire polygon with a single color regardless of lighting or shading effects. Next, garage shading. A smooth shading technique where colors at the vertices are interpolated across the surface of the polygon. The third one is texture mapping. It involves applying a 2D image or texture onto the surface of the polygon. Scanline algorithm. This algorithm processes the polygon one horizontal line at a time. It calculates intersection points of the scanline with the polygon edges and fills pixels between these points. Flood fill algorithm, a recursive algorithm that starts from a seed point that is inside the polygon and fills adjacent pixels until it reaches the boundary. It is commonly used in paint bucket tool in graphics software. Edge walking algorithm. This algorithm traverses the edges of the polygon in a systematic manner, filling pixels as it moves along the edges. Let us discuss the algorithm in detail. In scanline algorithm, first we have to divide the polygon into horizontal scanlines, determining the y coordinates that define each scanline. Next, we have to calculate intersection points by finding where the scanline intersects with the polygon edges. And third, we have to fill the pixels between the leftmost and the rightmost intersection points for each scanline. Flood fill algorithm. First, we have to choose a starting pixel inside the polygon. This is often done by clicking on the area to be filled. Then we have to recursively fill adjacent pixels by checking neighboring pixels and filling them if they are within the polygon boundary. Edge walking algorithm. In edge walking algorithm, first we have to traverse the polygon edges in a clockwise or counterclockwise direction, keeping track of the current edge. Then we have to fill the pixels between the edges as we move along, ensuring that the interior of the polygon is filled. Boundary fill algorithm. The boundary fill algorithm is a technique used in computer graphics to fill an enclosed area with a specific color. The algorithm begins by selecting a seed point inside the object to be filled and continues to fill the area until it encounters a boundary that has different color. We have to ensure that the color of the boundary and the fill color must be different for the algorithm to function correctly. The algorithm assumes that the boundary color is uniform throughout the object. The filling can be performed using either 4 connected or 8 connected pixels. Let us discuss these in detail. 4 connected polygon filling. In the 4 connected technique, only the pixels directly adjacent to the current pixel, that is above, below, left and right, are considered for filling. Let us see the algorithm steps. First, we have to initialize the set of values of the seed points, fill color and the default color. Next, we have to define the boundary, that is to identify the boundary values of the polygon. Third, we have to check for the color. If the current seed point is of the default color, continue to the next steps until a boundary is reached. The fourth step is to set the color. Change the default color at the seed point to the fill color. And the last step is the recursive filling, that is to recursively call the filling procedure for the 4 neighboring pixels, that is up, down, left and right. The algorithm terminates when all reachable pixels of the default colors are filled. Consider the case shown below, where we try to fill the entire region. Here, the image is filled only partially. In such cases, 4 connected pixels technique cannot be used. This is a limitation of the 4 connection technique. 8 connected polygon filling. The 8 connected technique expands upon the 4 connected methods by also including diagonal pixels in the filling process. This allows for a more comprehensive filling of the area. We can discuss the algorithm steps. First, we have to initialize, set the value of seed point, fill color and the default color. Next, we have to define the boundary, identify the boundary values of the polygon. Third, we have to check for the color. If the current seed point is of default color, continue to the below steps until a boundary is reached. Next, we have to set the color. Change the default color at the seed point to the fill color. Next, we have to recursively fill. Recursively call the filling procedure for all 8 neighboring pixels. These are up, down, left, right, top left, top right and bottom right. The algorithm terminates when all reachable pixels of the default color are filled. Now let us discuss some applications of the polygon filling. In the area of video games, it is used extensively to render 3D models, environments and characters, providing the visual depth and detail needed for immersive experiences. In the area of simulations, it is used to visualize complex systems such as physics simulations or architectural designs, allowing users to see realistic representations of data. In the area of graphic design, in graphic design software, polygon filling techniques are used to create visually appealing graphics, illustrations and digital art. Let us revisit. Polygon filling refers to the process of coloring the interior of a polygon in computer graphics. A polygon is defined by its vertices, and filling it involves determining which pixels or areas within the boundary should be colored. Polygon filling is crucial for rendering shapes in 2D and 3D graphics. It is widely used in applications such as video games, simulations, and graphic design to produce visually appealing images and models. Thank you. Hope these references find useful.